Hello students, welcome to ShirtBack Academy. In our lesson today, we're going to be beginning Module 2, Infrastructure. In this lesson, we're going to be covering Section 2.1, Input-Output Device Interfaces. Let's begin. The first interface type we're going to discuss are registered jacks. Registered jacks are a modular connection that's used for cord plugging. It has an internal 6-wire position connector. An RJ connector can hold up to 3 telephone line connections. 2 wires equals 1 connection. RJ11 is the most common connector for single telephone lines. It's a 6-position 2-conductor connection. RJ14 is a 6-position 4-conductor connector. It's used for dual-line telephone wire connections. RJ45 is a standard jack for modem and data interface connections. It uses wiring in all 8 connection points. Here to the right is an example of an RJ45 wiring standard. RJ48 is the standard jack for T1 copper internet lines. It is a 4 connection point. Here is a picture of RJ48 wiring connection. Bluetooth is a personal area network technology. Personal area networks are abbreviated as PAN. Bluetooth enables high-speed data transfers over short distances. The Bluetooth range is typically about 10 to 20 feet. All Bluetooth devices must have connectivity with each other. If one device is not Bluetooth enabled, no connection will exist. Some common Bluetooth use cases include smartphones and watches, external speakers, headphones, and fitness monitors. NFC stands for Near Field Communications. NFC technology allows us to use our smartphones to transact financial payments. We do this by exchanging information over a short-range wireless connection. Our smartphone will use an encrypted access token that is sent to us wirelessly from our payment system. Our smartphone sends back an identity token that completes the transaction. We can also use NFC technology for things like gathering customer data forms or accessing portals. RFID stands for Radio Frequency Identification. RFID uses electromagnetic fields to identify and track tags. An RFID tag uses radar technology and a tiny radio receiver and transmitter. An RFID reader will identify the tag and transmit digital data through short-distance radio waves. A passive RFID tag requires signals from a reader. Active tags have a built-in battery. We use RFID in many cases, including assembly lines, implanting pet microchips, and employee ID cards. USB stands for Universal Serial Bus. It's an industry standard of cable and connector types. We use them to provide power supply between our computers and a peripheral device. Here to the right, we have a screenshot of many different USB connection types. On the top, we have USB 2.0, and on the bottom, 3.0. Many of the peripheral devices you're familiar with use a 2.0A or 3.0A connection. We typically use the 2.0B and 3.0B for peripheral devices such as printers. We have 3 different standard cable types in USB: 1.1, 2.0, and 3.0. Each of them have their maximum throughput speed and cable length in the table. USB Type A is the most common connection. It's a 4-pin connection and is a rectangular shape. You're familiar with it with most of your peripheral devices. Type B is used mostly with printers. The mini USBs, both the A and the B, are 5-pin connectors. They're used mostly with MP3 players and digital cameras. The micro USB are normally used with GPS tracking devices and photo printers. USB-C is the newest USB technology. There are 2 new features with the USB-C connection. First, it's double-sided. It's a symmetrical connector, which means it will work no matter which way we plug it in. Secondly, USB-C has a 24-pin connection. We can use it for both host and mobile devices, and it also supports analog signals. VGA stands for Video Graphics Array. VGA is an analog video signal. It's used with monitors, video cards, and projectors. We know the VGA signal because it's normally colored blue. VGA is a 3-row, 15-pin DE15 connector. Over here to the right is a screenshot of a VGA connection. VGA only carries video signals, it only carries analog, and up to about a 10-meter cable length. HDMI stands for High Definition Multimedia Interface. It's a video cabling type that transmits digital audio and video signals on the same cable. HDMI is the first single cable technology that replaced analog video. HDMI cabling requires the display device to have compatibility. HDMI is frequently used with monitors, digital televisions, and video projectors. HDMI is a 19-pin connector. It has a cable length of about 20 meters. There is a mini HDMI standard that's a smaller standard used for digital cameras and camcorders. DVI stands for Digital Visual Interface. There are 5 types. They are all listed in the screenshot to the right of the screen. The 3 common signal types to be familiar with are DVI-A, D, and I. DVI-A carries only analog signals. The A stands for analog. DVI-D carries digital signals. The D stands for digital. DVI-I carries both digital and analog signals together on the same link. Review the interfaces to be familiar with each type. Thunderbolt is an Intel hardware interface that connects external peripherals to a computer. Thunderbolt 1 and 2 uses the mini DisplayPort interface and has a 20 gigabit per second data speed. Thunderbolt 3 uses USB-C connections and has a 40 gigabit data throughput. Thunderbolt copper wire connectors will typically have about a 3-meter range. Thunderbolt fiber connectors will have about a 60-meter range. DisplayPort is a digital display interface developed by VESA, the Video Electronics Standards Association. It's a royalty open source free standard. It's available for use by any manufacturer. DisplayPort connects an originating video source to a display monitor. It can carry audio, USB, and other data types, and is compatible with HDMI. Apple created a mini DisplayPort that's commonly used with its MacBook computers. The two connector types are in the screenshot to the right. That will conclude this lesson. If you have any questions about the contents of this lesson, please review the downloadable course notes for Section 2.1. In our next lesson, we'll cover Section 2.2, PC and laptop peripherals. We thank you for following along today. We'll see you in the next lesson. Enjoy the rest of your day, everyone.